Yeah, thanks. The to-do API is actually, or the JWT has some benefits for the to-do API. One of the benefits is that it can be validated without ever talking to the user API. And we'll talk more about how that happens, but that signature is a key part of it. And then the other thing is that JSON Web Token actually can contain a bunch of other information. So the to-do API can get the user data from the user API via the JWT and be assured that it hasn't been tampered with without ever making a call directly to the user API, which is the big win. And that's that stateless nature of the JSON Web Token. So as I mentioned, you can sign it in a couple of different ways. We'll talk about public-private key pairs and why you might choose to sign with them in the in I don't know 10 or 20 slides. But that validation piece is really, really important. And then the ability to stick other information in a JSON Web Token that would be useful to the consumers of that JWT is really valuable as well. So let's actually look at like the nuts and bolts of a JWT. So here is a signed JWT. All signed JWTs have three clauses. They have a header, which is in green, a payload, which is in blue, and then that signature, which is in white. And the first two are basically just base64 encoded. They're URL friendly base64 encoded to be precise. So if we were to take a look at that, you can actually cut and paste this into any base64 decoding tool, and you'll see the JSON. So I actually, whenever I'm looking around at URLs or in other in dev tools in a browser, I look out for that EYJH right up here, that prefix, because that is almost certainly a JSON Web Token. The header is metadata. So it's what algorithm the JSON Web Token was signed with and other information like that. The payload is where things start to get pretty interesting. This is your domain specific data, right? So this is what you want to convey about the user. And I'll talk about these claims in a little bit, but three that I want to call out that I'm not going to talk about later are the subclaim, which is who this JSON Web Token is about. So it's what also is called the principal in a lot of security literature. The name is just a claim that isn't standardized. You can put whatever you want in there. And then roles is also a claim that's not standardized. Oh, sorry. The keys of the JSON object here are called claims. So when I say the claim, I'm just saying the key that corresponds to sub, name, or roles. And roles just shows you that you can have complex JSON objects, right? Anything that it's not limited to just strings or Booleans or integers. Anything you can put into a JSON object, you can put into a JWT. And then it gets turned into that very nice string that you can pass around. The signature is, yes, go ahead.
There's a question from Praveen. He's asking, will it always be 64-bit encoded?
So it always will be base64 encoded. Yep. So that's how it's part of the specification that it's actually base64. I want to say URL friendly encoding. So there's no equal signs or anything like that, which basically lets you put it into cookies or put it into headers. But yeah, it'll always be base64 encoded. For signed JWTs, encrypted JWTs might be a little bit different. As I said earlier, I'm not as familiar with those. Any other questions right now? Awesome.
Thank you.
Thanks for the question, Praveen. So the signature, basically this is what verifies the integrity of the JWT. And so how it works is when you are signing the JWT at the user API, you are going to take the header and the body and concatenate them together, and then you run a cryptographic algorithm, and then you base64 encode that, and you stick it into the third clause, which is the signature. Anybody consuming the algorithm, or sorry, consuming the JWT can do the same thing, right? They can get the header, get the body, and run through that signature process. And if that signature doesn't match, you should stop processing. And this typically, to be frank, isn't something you're going to do on your own. This is going to be something a library takes care of for you. So let's talk about validating a JSON Web Token. So this, don't forget, a JSON Web Token is a portable measure of identity. And so, or it's a token of identity. So you want to make sure that you don't just accept it blindly. You need to actually do some validation when you get it as a consumer of a JWT. So the first thing, as I kind of implied earlier, is you got to validate the signature. That is going to depend on the metadata, right? Because that tells you what the algorithm was used, what algorithm was used. And again, most libraries, most languages, Java included, have a number of libraries that will help with this aspect of it. Then you also need to validate the claims. And this is where I think some people don't do this, right? They just assume the library is going to take care of it all for them, and the library helps some, but there's some business logic that you have to take care of. So there's top three claims: the ISS claim, the EXP claim, and the odd claim. You should verify those every time you see a JSON Web Token. So let me kind of walk through those. So the ISS claim is who created this JSON Web Token. So in the architecture or in the application we talked about earlier, the to-do application, we're talking about the user API. And it doesn't really matter what the string is. As I've seen domain names, I've seen HTTP, I've seen URLs, excuse me. I've seen random strings, I've seen UUIDs. It doesn't matter what it is, as long as the producer of the JSON Web Token and the consumer of the JSON Web Token agree on what a valid value is. The next is the expiration time. So because JWTs are stateless, because you're not checking in with the user API to say, hey, is this JWT valid? They're time-based. So if your expiration time is in the future, it's a valid JWT. If it's in the past, it is not a valid JWT, and you should not process it any further. This is the number of seconds since the Unix epoch, and is pretty standard. Like that's one thing that I've seen. I've seen the values for claims vary across different providers, but this is actually part of the standard, is what that expiration time is. The final claim you should verify is the odd claim. And odd stands for audience, or is short for audience here. And again, this happens to be a FusionAuth audience claim, but it doesn't really matter what the value is. What matters is that the issuer of the JSON Web Token is putting this value in, and that you as a consumer are checking to see that that represents you, because the odd claim is who this JWT was created for. So you could imagine that if your identity provider or your user API is creating JWTs for different APIs or different applications, it's possible somebody sinister could find a JWT that was designed for the for some other API or some other application and present it to the to-do API, or vice versa. And it doesn't have to be someone sinister. It could just be some misconfigured client. And to be honest with you, the retrieve to-dos role means a lot to the to-do API, but it probably doesn't mean a lot to other APIs. And so that's why you need to make sure that you check the audience claim before you continue down the path of allowing access for the client to whatever resource you're protecting. I'm going to show you. Yes.
Dan, this is Steve Afrin in Salt Lake City. Can we go back and talk about the expiration
Sure.
field? Because you talked about that with seconds since the epoch, but Nils in the chat said so the standard won't work in 2037. Can you talk about what might happen with this expiration in 2037? Because that epoch is going to be an issue.
So I've not heard that before. And I know that 2038 is when the Unix int32 rolls over, but this is not defined as a int32, I don't believe. I think it's just defined as an integer. So I'm not going to speculate because I haven't heard about that before. I would expect it would just keep working because the backend systems just need to be converted to int64s, which they do anyway. But I can't speak further because I don't know.
Okay, cool. Thanks.
Yeah, that's a fair question. I'm going to actually make a note of that and see whether there's anybody else who's kind of written about that. By the way, you should not be creating JWTs that expire in 2038 right now, but we'll talk about that later. And I understand you're thinking about future-proofing your system, so I get that. All right, let me go ahead and
It's Rahul also has a question in the
Yeah.
chat there. I think it hasn't been asked yet, right, Rahul? So he said in signed JWT using a symmetric PKI, the public key must be passed for validation. Which part of the JWT field holds it?
Great question. And actually, Mary, I just figured out how to watch the chat, so I'm not going to make you do
Okay.
that anymore.
Okay, great. All right. I'll let you
Yeah.
read.
So the question is, how do you get access to the public key? And I'm going to talk about that in maybe 10 or so slides. So let's hold that question for now. And Rahul, if I haven't answered that question by the end of the talk, let's revisit it. Okay. All right, so I'm going to show some code right here, and this is a open source repository. The license is the Apache 2, and it has just some examples where you can pull down some Java classes and run them to play around with JWTs. And so right here, we have a class that actually checks claims in the way that I explained that you should. And this is not a normal situation, but basically you can pretend that lines 18 through 38 are the user API, which is creating the JSON Web Token. And then the subsequent lines are actually the to API, which is verifying the token. So this happens to be using an open source library that FusionAuth puts out, but it doesn't really matter exactly what it is. And you can see that we can add other claims. Let's add a claim of favorite color is always a good one. I like blue myself. All right. And so then what we're going to do down here is after line 40 is we're actually going to check the claims. And so you can see on line 43 and 44, our to-do client knows to expect the issuer of FusionAuth and the audience of that UUID starting with 238. And then we're actually doing the check on line 48. So on the library, and this is pretty common across libraries I've seen, the library actually takes care of checking the signature and checking the expiration time. But the other things, the issuer and the audience, are on us to check. And if there were anything else we wanted to check, we could also check, whether or not a user is a premium user or other kind of business logic specific attributes here. Let's go ahead and run this. So you can see we output this string. This is our JWT that, again, is URL friendly. We can pass it around. And this is our decoded JSON Web Token that we can then use to actually get access to resources that we want to get access to. I'm going to prove that we actually do check those claims. If I change this to 138, we're going to get an exception because we are no longer the audience for the JSON Web Token. So we get invalid claims, and then we shouldn't process this anymore. So again, the link to this, I can share this with Mary. I can post it to the meetup. It's at the end of this presentation. And it just, there's source. There's HMAC in a couple of different ways, and then there's the RSA. There's a JWT that's signed with a public-private key pair. All right. So, any other questions right now? When we
Yeah, I have a question. This is Matt from Chicago.
Hi, Matt.
Is it possible and even recommended in terms of the security best practices to skip or strip the header from the JWT or job, which contains the algorithm and the key, right, which could be misused, as you pointed out. And I think it's one of the main JWT security weak points.
So you're saying, can you strip it and still use JSON Web Tokens?
Right. In other words, is it necessary to include a header which contains those two pieces of information, algorithm and key ID?
So you could strip those off if you had some other way of communicating that, right? Some other out-of-band way of communicating those two pieces of information. However, it wouldn't be a JWT at that point, right? It would just be a token that you had signed using, whatever the method is and with whatever key it is. And you could absolutely do that in your system. What you're going to lose is some of the flexibility around like key rotation and also the libraries. So you will be responsible for, and you could take an open source library and hack it up to say, always use this key identifier and always use this key, this public key to verify things, and always use this algorithm. You're just losing some of the flexibility.
Right. So because I think this is well-known security issue discovered a couple of years ago that the attacker can modify the algorithm in the header, right, to even prevent the validation. I've read the article that if you even pass the value for the algorithm none, that stopped the validation of the keys, etc. So,
well, no, I mean, and you need to be careful.
That was pretty scary. But anyway. So they come up with the idea of the headless JWT, and I was wondering, what do you think about that part?
I mean, I've not heard of this before. I've definitely heard about that article where basically what they're doing is they're swapping out like I think it's HMAC for RSA or RSA for HMAC in the header, and then it's an attack that
right, exactly, yes.
But the answer there is really you should check the key identifier and make sure it's the correct algorithm before you do any processing further, right? So there's some responsibility on the person that is receiving the JSON Web Token to make sure that things are all in line, for sure.
Okay.
Yeah.
All right. Okay.
But I haven't heard, so I'll look into. Actually, thank you for letting me know. I have not read about headless JWTs. It'd be interesting to learn more about those. So. Like I said, kind of at the beginning, they're powerful tools. They can be misused, and we'll see some of the other ways they can be misused in later slides.
Right.
Cool.
Yeah. Thanks. Yeah.
Thank you, Matt.
Thank you.
Great. So when you use the JWT as a bearer token, you want to be cognizant of any risk or of every risk that always happens with any bearer token, right? So this is not JWT specific. This is just a warning because JWTs are often used as a bearer token. And what a bearer token is it's kind of like a car key. So if I have my car key and I give it to Matt and he's next to my car, he can hop in the car and turn it on and drive away. If he finds it lying around, right, and he happens to be able to identify which car it goes with, he can do the same thing. Not that I think Matt would do such a thing. I'm just using him as an example. JWTs are the same way. So that means that if somebody else, a bad actor, finds a JWT that a user has legitimately created, they could do this in a couple of ways, right? They could do it via man in the middle. They could do it via JavaScript looking through local storage, because sometimes people store JWTs in local storage, which is a horrible idea. Please don't ever do that. But some systems still do. I believe AWS Amplify does. I was watching a thread about that a couple of weeks ago. They could find it in a log file. They could find it if you put it in a get string, which I've seen that happen too. It could be in a proxies log file or something like that. Anyway, they can find this JWT and then they can present it to other APIs as if present it to other APIs, and that API will react as if the JWT was presented by the person that created it, or the person for whom it was created, right? The Drew API right here, because it's stateless, doesn't have any idea who this JWT is from. It's going to trust the JWT itself. So you have to be careful about how you store JWTs, basically. You want to, we recommend preferring server side. So that means basically storing it in the session on the, you store it server side in the session, and this is known as the BFF pattern. And basically your client presents a session cookie or some other session identifier, and then the JWT stays server side so that no one can find it and pick it up. We realize that doesn't work for everybody. So if you want to push it down to the browser or to a native client, just make sure you store it securely, either as a cookie that is not accessible to JavaScript or in secure storage on mobile devices. So here's some common issues that we've seen people run into with JWTs. The first is there's a lot of configuration options. Like Matt said, there's some you can very easily, if you're doing things yourself. Well, you didn't say this, Matt. I'm going to take it as an implication. If you do things yourself, you can screw things up pretty badly. So I highly suggest using a library. There are a number of open source libraries out there, and you also need to make sure you verify your claims the way that I walked through previously. You can't just rely on the library to check the signature and the expiration and assume everything else is good. It's important to realize that JSON, that the power of JWT is that it can contain arbitrary JSON data, but that also means if it's a signed JWT that you can put stuff in there that you might not want other people to see, but there are no secrets in a signed JWT. If anybody gets a hold of it, they can look at that. So the JWTs that you saw earlier in my slides, you could cut and paste those into a JSON, a JWT debug tool, and you would see the same contents that I showed you, because it's basically base64 encoded data with a signature. So just one thing to emphasize, if you use a JWT and it's a signed JWT, make sure that you understand that the contents in there are not secret. So that means, what are you going to do? Well, you don't put secret data in there, right? You don't put social security numbers or private data, but you can put references, right? So if you remember that JWT, like the sub claim was a UUID, the odd claim was a UUID. And so those are things that aren't leaking data the way that an integer or some other kind of more meaningful data structure might leak. Another foot gun is if you use a symmetric signing algorithm, which is HMAC, you want to make sure the key is nice and long, because otherwise, if someone has just the JWT, they can try to brute force that key, right? And just try different keys. And if they end up finding, try different keys, run through that signing algorithm, and if they find a key where the signature matches what the JWT has in it, then they have found your key, and then they can sign JWTs that are functionally equivalent to JWTs that are created by your user API. This is something that comes up a lot when people talk about JWTs. They say, oh, it allows a none algorithm where you don't have a signature. What a boneheaded move. And what that does is that changes the JWT from looking like this to looking like this, where there are still 3 clauses, but there's no signature. The signature is empty. That means that the header changes from this to this, and that means that anybody who actually finds a resource that accepts JWTs without a signature can create their own payload and base64 encode it and create their own header, which is pretty easy to do, and send it to your API. That's a horrible idea, right? Because you don't want to just accept arbitrary input from an API for something that is supposed to be credentials. We're not just talking about unsanitized input here. We're talking about unsanitized credentials, which is just a super scary thing to me. So the specification allows this, but the simple fix is just don't ever allow none. Don't ever create JWTs with a value of none. Don't ever accept them with a value of none. There are exceptions, and I'm happy to speak to those if you have questions about them, but they're pretty few and far between. So let's talk about asymmetric key pairs. This is touching on Rahul's question. So we have this API, this set of APIs, and if we're using a symmetric signing algorithm, then we have the same key, which is held on the user API to sign the JWT, as is held in the to-do API to verify that the signature is valid. If instead we use an asymmetric situation, right, where RSA or elliptic curve cryptography, then the user API signs the JWT with a private key, and then the to-do API verifies the JWT with the public key. And this solves a couple of problems. The first is that you don't have to worry about distributing a secret key anymore, which is pretty easy to do when you have 2 APIs, but if you have 20, it might be kind of more difficult. And then it also solves a security issue. So the security issue is that, again, just as if someone found your symmetric key by brute forcing it, if someone finds it by breaking into the to-do API and looking in memory or in a configuration file or someplace else, if they can find that key, they can then sign JWTs that are indistinguishable from those that are created by the user API, which obviously is problematic. It also scales organizationally better because you don't have that distribution problem. You can even have the user API be run by a company that is entirely different than the company that is consuming that JSON Web Token. And as I mentioned, it's a better security posture. There isn't any such thing as a free lunch, and public-private signing is a little more complicated and it's a little bit slower. I haven't tested it in Java, but I did it in another language and it was between 2 and 10 times slower. Although I would submit that I don't know that your JWT signature verification is the slowest part of any application. I would say profile it to make sure that was a problem. So how does this work? Well, what happens is the user API signs the JWT with the private key, sends it to the client. The client sends the JWT up to the to-do API. Now, for the to-do API to validate that signature, it needs that RSA public key. It can get it via the file system, right? That public key can be just distributed with the to-do API. And the benefit of that is that now the to-do API is totally disjoint from the user API. It doesn't need to access the user API. They could be on totally separate networks. But the downside is rotating keys requires a new deployment, possibly. A more common pattern is for the to-do API to reach out to a well-known endpoint. This is another standard. I don't remember the number of it, but JWTs is an IETF standard as well. And at that endpoint is a list of public keys. Because guess what? They're public. The user API wants everyone to know about them. It doesn't need to keep that secret. That endpoint looks a little bit like this. That is some pretty small text. So here is a subset of that. And the important things are the algorithm, the key identifier, and then the actual base, I think it's base 64 encoded value of the key, the public key. So with this, there is a private key that corresponds to this identifier, right? The UK0 identifier. And any JSON Web Token that gets passed in with that identifier, the to-do API needs to validate that the algorithm is the same and know that the JWT was signed with the private key corresponding to this public key. And so that public key is what it should use to verify the signature. Any questions about that stuff? Yeah, Rahul, that I can help. All right, and move on since we're close to running out of time. Refresh tokens are an important part of any JWT-based system, and JWTs are supposed to be short-lived, again, because of that bearer token issue. Refresh tokens can be much longer-lived, and refresh tokens basically can be used to be presented to the user API to get, or to your IDP, your identity provider, to get new JSON Web Tokens. And there's a spectrum here. If you imagine a world where refresh tokens didn't exist, you would have two choices. One, you could have your JWTs be short-lived, which meant that every time a JWT expired, you'd have to have the user go through the whole authentication process, which is obviously not great UX. Or you could have your JWTs be long-lived, and your users wouldn't have to go through the authentication process regularly, but if anybody, bad actor, whatnot, found the JWT, it would be good for a long period of time, right? And that's bad too. So how does this work? The user API creates a refresh token at the same time as it creates a JWT, and it passes that refresh token and the JWT down to the client. And let's say our JWTs are good for 5 minutes. So for 5 minutes, the client is interacting with the to-do API, happily creating to-dos, marking them off, deleting to-dos, assigning them to other people, whatever the functionality is. At the end of 5 minutes, the to-do API looks at the JWT, which every time a request is coming in, it's checking all those things. It's checking the expiration time, checking the signature, checking the audience, checking the issuer. The expiration time is no longer valid. Or sorry, the expiration time means that the JWT is no longer valid because the expiration time is now in the past. So the to-do API says, hey, buddy, I'm shutting you down. You're not getting any more to-do access right now. The client can catch that exception and try to deal with it. And one way it can deal with it is say, oh, actually, I have the refresh token. I'm going to go see if I can get a new JWT. So it presents the refresh token to the user API, and the user API says, yes, that's a valid refresh token. The user's still logged in. The user's account is still active. I'm going to give a new JWT to this client. So the JWT gets sent back to the client, and the client can then present that to the to-do API. And for another 5 minutes, things are good. So basically the user is silently, not really re-authenticated, but silently refresh their JSON Web Token. As far as logging out, basically you're limited to revoking the refresh token. And how that works is the client says, the user says, hey, I want to log out. The client says, okay, sends a message to the user API, hey, revoke this refresh token. Don't let anybody use it to create new JWTs. And then the client will delete the JWT and the refresh token on the client side. We get this question a lot. Can you revoke JSON Web Tokens? And the answer is sort of. If you have a JWT that's been stolen or that you otherwise need to mark as invalid, you can rotate keys, because if that key identifier comes in and there's no corresponding public key in the JWKS endpoint, that key, that JWT is invalid. And so that has the downside of every JWT that was signed with that key is no longer valid. So you basically logged out a ton of people. So Praveen asks, after the first refresh, is the refresh token the same? So let's go back to that slide real quick. So that is a implementation specific detail. So OAuth 2.1 actually recommends that you have the refresh tokens be one-time use. And OAuth 2.1 is basically a consolidation of OAuth specifications over the last 10 years into kind of a best practices doc that is currently being worked on by the IETF. So one option is you have the refresh token be one-time use. Another option is you bind that refresh token cryptographically to the client. But there are other systems out there that will happily let a refresh token be used multiple times. So it is an implementation choice, but in general, refresh token is longer lived than a JWT. Praveen, does that help?
Thanks.
Great. All right. So we're talking about revoking refresh tokens, or sorry, JWTs. The other option that I've seen that's pretty common is the deny list, which basically means that when a refresh token is revoked or for any other reason, you can fire off a webhook to all the different APIs that are consuming your JWTs, and you're basically pushing state back down there so that as part of the validation process, you're not just checking the audience, the issuer, the expiration time, signature. You're also checking against this data store saying, hey, has this JWT been revoked? And that's a valid way to do this if you need the ability to revoke JWTs pretty quickly. Another way to do it is just make your JWTs have a really, really short expiration time. As far as JWTs and Java, hopefully this has given you a good sense of when you would use a JSON Web Token in a distributed system. If you're thinking about trying to accomplish things with them, if you're generating or parsing JWTs, please use a library. There's a lot out there. If you're doing authorization, this is a perfectly natural thing to put into a library to do that kind of level, or at least a shared bit of code to do all that validation. And Spring actually provides a JWT authentication provider. Here's some extra information. As I said, I'll post this on the meetup. One thing that I'd call out, or two things I'd call out. The second bullet point is that GitHub repo that I mentioned that I showed you some code from. The third line item is a 3,000 word essay I wrote about how to build a secure JWT from various angles. That's it. Thank you very much. I think we have some giveaways. If you want to learn more about FusionAuth or how we think about OAuth, this is an 80-page ebook that you can get for free if you go to fusionauth.io/ebook. And really appreciate the questions, and I appreciate your time.
Thank you, Dan. Yeah. I guess we can have a couple minutes if folks have more questions too at this point to ask Dan.
Thank you, Steve.
Any more questions? I'm sure you are very reachable, right, Dan? Anybody can message
There's my
you.
email address right there. So yeah,
go
ahead.
I have a quick one. What is your take on encrypting sensitive attributes in the payload?
So kind of as I mentioned at the beginning, I don't have a lot of experience with that. I think that it can be part of a defense in depth strategy, right? There are lots of ways you can tie down JWTs or the systems that are using JWTs for their identity system. I'm going to plead ignorance because I honestly haven't even played with them, right? I haven't even written code to encrypt a JWT, but I don't see why it'd be any different than encrypting any other piece of data that you're passing over the wire. It's pretty solid as long as the algorithm you're using is solid.
Right. Yeah. So my next question is: your platform that you're working on, FusionAuth, provides encryption of the attributes when you generate the tokens?
Nope.
Okay. Yeah. Thanks.
Yeah, of course. So Nasir says, can we apply filters on JWTs? What's the limit? Are you, Nasir, do you mean what's the limit on the length of a JWT, or I'm not sure I understand your question. Thanks, Ashley. And Rahul asks, while Nasir's answering my question to him, does Java define an APA specification for JWT usage? I don't know. I did have someone at a past jug that I talk about the JWT micro profile, and I had a note to look at it before I gave another presentation, and I haven't done that, so I don't know.
Should check that too. That's a good question. Right. And did Nasir clarify his question?
I have not seen that get clarified yet.
That's right. Nasir, do you want to turn on your audio? Maybe you can ask directly if you like, Nasir. No? Maybe lost connection? Must be something.
Yeah. Feel free to, Nasir, if you see this later, feel free to send me an email with more details about your question. I'm happy to answer. I just don't understand the question right now. So
I'm scanning through. I think looks like, yeah, everybody's compliment, and I don't see any other questions, new questions.
Great. Okay.
Okay. So I guess if there are no
actually, I have one more.
Please do.
You mentioned the problems that the JWTs try to solve or help to solve.
Mm-hmm.
So here's the scenario. You need to implement a login part for your application, right? The reason for that is because you have some resources, like for example, you provide some games to play on your website, but you want to only show that resource for the authenticated users. So how would you approach that scenarios? What are the options to implement that? I'm not talking about the details. I just want to see how the JWT would fit in, if possible, as one of the good options to use.
Sure. So my consulting rate is $250 an hour. No. Sorry, that was my attempt at a joke. I would say that you could use JSON Web Tokens. You could use. It depends on where these other games are, right? Like if they're living on totally different servers, if they're all directed, if they're all hanging out behind.
Let's simplify the same server. Let's simplify the same server.
Sure. Then you could use sessions, right?
Okay,
Which are
right,
kind of like
yeah.
an old school, but still pretty solid for that thing. I mean,
Right.
here's the thing. Like, I think that I would make the argument if someone came to me and said, hey, it's all on the same server, it's all fronted by the same application server, that sessions would be and it's browser based, right? Then sessions
Right.
are a really good option because they're kind of well known, well understood. JWTs are better for distributed systems where you don't have that kind of level of centrality.
Okay, how about just a simple database authentication, right? Old school even.
Sure. I mean, so the question of how you create the thing that so you're talking about like having a database where you have a username and password and
Right.
yeah, I mean, so the issue there is that's fine to start out with, although you do need to learn something or use libraries, open source libraries or whatnot to take care of your password hashing and making sure that data is secure. The other issue is what happens if you want to add a forum to this game site and you want to use some forum software that you don't want people to have to log in twice, right? Like,
Right.
okay. So that's where separating things out to an auth server like FusionAuth, or there are others out there, it's not the only one, is good because then you get to start to have single sign-on, which is a different class of problem than JWTs, but is related. So, but yeah, I think simple. If you came to me and said, "Hey, I'm starting things up," and you didn't think that you were going to start to hang other applications off of your single application that you'd want other people to be able to log into, I would say, using open source library to handle the auth and then just doing session, right? Because that database table, at some point you're going to be storing, hey, this person's authenticated and I'm going to store their user object in this session. And then that cookie is going to kind of be going back and forth between the client and the server. And when that cookie is presented, I know this is Dan Moore or this is Matt, and they have different access to different games. So it's still session based to some extent.
Mm-hmm. Okay, yeah, thanks.
Yeah, you bet.